We will continue for that previous class graph. Already we do this one. We were drawing the graph between kinetic energy of reactant and fraction of molecules of reacting molecules. Okay, we studied the same reaction at a T temperature and T plus 10 degrees Celsius. So total concept is based on difference in the 10 degrees Celsius is the concept. Okay, at a 10 degrees temperature, ABCD is the area. Means that it gives the information regarding fraction of molecules means reacting molecule which are having kinetic energy is greater than activation energy. Means this number of reacting particles only going into activated state, undergoing effective collisions and converting into products. Okay. Now, at T plus 10 degrees Celsius, we have area, ABEF area will be there. That area is also gives the information regarding fraction of reacting molecules which are having kinetic energy greater than or equal to activation energy. Already we learned in the previous class division. Now, our concept is what? For every 10 degree range in temperature, how rate constant value is becoming minimum double up to maximum triple. That is our concept now. Okay, for getting clarity, ABEF area is equals to 2 to 3 times of ABCD area. Are you agreeing for this one? Yes, why? Because ABCD area is nothing but this much. But ABEF area means the total area. The total area is almost double, more than double of ABCD area. That will be arrayed. So that this is the information at T plus 10 degrees. This is the information at temperature T. So ABEF area, what happening? Fraction of molecules or doubles the minimum we are discussing, doubles the fraction of molecules having their kinetic energy is greater than or equals to activation energy. Means this number of molecules is almost double the ABCD area at a T temperature area. As it double the number of double the fraction of reacting molecules increasing, means what? Most of the molecule is going into activated state and they are involving in the chemical reaction. Automatically what happening? Doubles the number of effective collisions. Doubles the number of effective collisions. Okay, you suppose number of effective collisions will be doubles. Automatically what happening? The speed will be also being going on increasing. Automatically it will doubles the which one? Rate of reaction. Rate of reaction is denoted by which one? Small r. If rate of reaction is doubles, we know relation R is directly proportional to K. Rate is doubles, rate constant is also becoming double. That's why we are telling it's doubles the rate constant, doubles the rate constant. So means is nothing but K value also doubles. Means for every 10 degree rise in temperature, rate constant value is becoming doubles than the T temperature. Why? Because he asked 1 or 2 times this point. Why rate of reaction or rate constant value will be becoming double for every 10 degree rise in temperature? Is a key point is nothing but almost doubles the number of effective collisions. What is the meaning of effective collisions? The collisions which are going in activity state, they definitely converting into products. Should write like that, not write out. Already you know this one. So that's why we are writing finally rate constant at T plus 10 degrees is equals to 2 to 3 times. Minimum 2 up to maybe triple, but generally we are considering double. Then the rate constant at temperature T. Already you seen this information. All of you clear? Yes. Now, in this March examination 2020, he asked me this question only. That is nothing but Arrhenius equation. Arrhenius equation. What is this equation and everything we will discuss. Arrhenius is one of the scientists. He given a relation between rate of reaction indirectly means what about speed of reaction and Fraction of molecules. Fraction of molecules means reacting molecule which are having their kinetic energies greater than or equals to activation energy. Arrhenius is one of the scientists. This question will explain or what is Arrhenius equation. He asked for 2 marks. This March examination. He given the relationship between rate of reaction and fraction of molecules which are having kinetic energies greater than or equals to activation energy. So means just now we told as the doubles the fraction of molecules increasing, effective collision increasing, effective collision is increasing, rate constant is also increasing. So what he given relation initially, rate of reaction is equals to, or otherwise rate of reaction is directly proportional to e power minus Ea by Rt. I will explain everything, don't worry. Rate of reaction is directly proportional to e power minus Ea by Rt. This is what we calling as fraction of molecule which are having their kinetic energy is more than activation energy. Can we write it equal to? Yes, we have to multiply with one constant A into e power minus Ea by R. Later we know R is directly proportional to K. From this what we can write it? Instead of R can we write K? Yes, K is equals to A into e power minus Ea by Rt. This is only we are calling as Arrhenius equation. Started information with rate and fraction, but finally we got relation rate constant and fraction of molecule. As it is right now, K is equals to A into e power minus Ea by Rt is calling as Arrhenius equation. But what are the terms in that one? Not right now. K is equals to yes, we know very well it is nothing but rate constant or velocity constant or also calling as a specific reaction rate. And later Ea, you know very well already in the previous diagram I shown that one. Ea is nothing but very good, it is nothing but activation energy. Yes or no? Yes. And capital R means what amount? Universal gas constant. Universal gas constant. And you know very well T is equals to what amount? Absolute temperature. What is the meaning of absolute temperature amount? The temperature should be expressed in Kelvins. Are you clear? And now I am telling one more time, it is nothing but e power minus Ea by Rt. The whole exponential term will give the information regarding which one? Fraction of molecules which are having their kinetic energy is greater than or equals to activation energy. The whole exponential term will give the information regarding the fraction of molecule. As the fraction of molecule is increasing, effective collision is increasing, effective collision is increasing, rate will be increasing. That's why the relation between speed and fraction will be directly proportional. From there we got rate constant is equals to this one. Okay, now here one important term is there now. A. What is the meaning of A? Constant. Which constant? Arrhenius constant. Arrhenius constant. So several names will be there. This is the previous term to the exponential term. That's why it is also calling as pre-exponential term. Pre-exponential factor. Are you ready? And A is also calling as collision frequency. One more name for A is nothing but collision frequency. For that chemical reaction, I think you know. Yes, once again you see what are the terms here that I will give some other explanation. In this K is equals to rate constant or velocity constant or specific reaction rate. A is Arrhenius factor, also calling as exponential term previous. So it is calling as pre-exponential factor. Ea is activation energy, R is universal gas constant, T is absolute temperature. The whole exponential term will give information regarding a fraction of molecule which are having their kinetic energy is more than activation energy. What are another names of Arrhenius factor or Arrhenius constant? Pre-exponential factor, also calling as collision frequency. What is the meaning of collision frequency? It's also very important thing. Collision frequency means is nothing but you know very well. Frequency, number of collisions between reactants, but the standard conditions you have to maintain a number of collisions between the reactants in 1 second time and 1 liter volume. We have to take 1 liter volume of the reactant, then in between them some collisions will be going on. Within 1 second, how many collisions will be happening? That what we are calling as collision frequency. Collision frequency value will be constant for the reaction. Constant for a particular chemical reaction at all temperatures. It's very nice point. Did you got my point or not? Once you check it. Arrhenius factor will be the constant for the reaction at all temperature. For example, you are taking En2 plus 3H2 gives rise to 2NH3. For example, I am telling Arrhenius factor is 2. For this chemical reaction, always Arrhenius factor will be 2. Whether you maintain 20 degrees, 30 degrees, 40 degrees and whatever. That's why Arrhenius factor for chemical reaction will be fixed or constant at all temperatures. And also I will take one more 2SO2 plus O2 is gives rise to 2SO3. What happening? Arrhenius factor will be changing because chemical reaction change. For this reaction, Arrhenius factor is equals to 3. But for this reaction, whatever temperature you maintain, A value will be fixed. What is the collision frequency? Number of collisions between the reacting molecule in 1 second time in 1 liter volume of the reacting mixture. All of you got it? Yes. Okay, from this Arrhenius equation now we are getting one far most important formula we are getting. You have observed very carefully. So what is the Arrhenius equation? K is equals to A into E power minus A by R. What I am doing? Both sides I am applying logarithm. Logarithm means what? For example, ln of K is equals to ln of A into derivation is not equals for you, but a competitive point of view is important every point. E power minus EA by RT. Very simple, you have to see carefully. Okay, left side ln of K only remains now, but right side you have to apply one logarithm formula, log of A and B. What will be coming? Right down here, log of AB formula, log of AB is equals to log A plus log B. Can you apply right side? Yes. What is coming then? ln of A plus ln of E power minus EA by RT. Are you getting that? Yes. Then we have to do simplification. ln of K is equals to ln of A. Again, one more formula we can apply. Log of A power x. Yes, right on here, log of A power x is equals to x log A. Use that formula also here. So what is coming then? The whole power term will be coming from minus of EA by RT into ln of E. What is the meaning of ln to the base E is the internal meaning. So again here this term becomes 1. Why? What is the formula there? Log of A to the base A is equals to 1. I simplified. Did you got it? Yes. Now to check it that one, ln of K is equals to, I am bringing that down to front, then we are getting minus EA by R into 1 by T plus ln of A. Just I am bringing this down to front, this down to second side. Okay, in this whole equation, some variable terms is there. Anybody? Activation energy will be changing for the reaction? No. Universal gas wants to be changing? No. Arrhenius factor is also constant for whole reaction at all temperatures. That's why I told you very clearly previously. What is the variable term here? Temperature changing. Temperature changing means 1 by T will be changing. As the temperature changing, correspondingly rate constant is changing. For every 10 degrees, it's becoming minimum double. So that's why here some important variable terms is there. 1 by T will be variable, correspondingly K variable means ln of K is also variable. Then it is similar to one of this right hand equation. Anybody? Y is equals to mx plus c. Here variable terms is x and y. Similar to 1 by T ln of K will be varies. From this I am drawing the graph. You have to observe very carefully. On x-axis, what has to be taken? This is important bit for competitive. On x-axis, what should be taken? 1 by T. On y-axis, what should be taken? ln of K should be taken. Then we are getting straight line with which slope? M is equals to what? Negative value. Negative value means straight line will come down. Very good. We are getting like this. What is asking in the competitive. In the IKS equation, if you float a graph between 1 by t versus ln of k, we are getting straight line with negative slope. What is the slope value? What is the slope value? M na. Instead of M, what will be there? Minus EA by R. Very good. If you can extend this straight line, yes, we are extending like this. It is having intercepting. The intercepting point will be nothing but C. Instead of C, what will be here? Ln of A. Again, we proved whatever temperature you maintain, ln of A value will be fixed. It should not be maintained. Yes, this value will be fixed for A value. It won't depend upon temperature. All of it. Yes, this is one of the important questions. Still, this is the first point. It's a very important point. This is the first graph. Second graph I am doing from the same concept. Ln of k is equals to minus EA by R into 1 by t plus ln of a. Just using some other information. We know relation between ln of x to the base e. Base length. Very good, 2.303 into log x to the base 10. Wherever ln will be there, we can substitute this term or not? Yes. Substitute in the previous 2.303 into log k to the base 10. No need to write every time. Log means to the base 10 only meaning is equals to minus EA by R into 1 by t plus. Instead of ln, should write down 2.303 into log a to the base 10. Still I am simplifying the whole equation divided with 2.303. Then what we are getting? Log of k is equals to, here dividing no, so minus EA by 2.303 into R into 1 by t. Any problem? This time from this side no. Yes, 2.303 cancel. 2.303 remains as it is. Here again 2.303 cancel. So what is coming now? Log a. Again in this variable terms is what? 1 by t varies correspondingly. Log k will be varies. Why? Because k is directly proportional to temperature. Yes or no? Yes. Remaining all terms will be constant for the reaction at all temperatures. Then I want to float a graph here. You have to check it very carefully. On it is similar to which equation? Y is equals to mx plus c. On x-axis and y-axis. X-axis what should be taken? 1 by t. On y-axis should be taken log k. Very good. Then we are getting straight line. That is slope is which value? Negative value. Quantity negative value. That's why straight line will be coming like this. What is the slope of this straight line? Slope is equals to minus EA by 2.303 into R. If you can extend this straight line, we are getting intercepting. The intercepting C is nothing but log A. Yes, log A. This intercepting is showing log A. In competitive questions, it's like this one. Under Arpeggios Equation, if you float a graph between 1 by t versus log A, we are getting straight line with the negative slope. That too, minus EA by 2.303 into R. From here to here difference is what we are taking ln of k means indirectly meaning is to the base e. That's why we are getting only slope is minus EA by R. Okay, now we are deriving some important formula what is helpful to us. Okay, you take it at a particular temperature T1, rate constant is how much? K1. You take another temperature T2, correspondingly what happening? Rate constant will be definitely changing. Yes or no? Yes. Okay. First of all, substitute this equation, the equation of this one. This one you can substitute. What is coming? Log of K1 is equals to minus EA by 2.303 into which one? 1 by T1 plus with the temperature Arpeggios factor will be changed. No. Then what is coming? Log of at a time you are getting two different temperatures and rate constant. That is a constant as us. What is the second one? Substitute that information. Log of at a temperature T2, K2 is equals to minus EA by R is 2.303 into R into 1 by T2 plus log of A. Is there any change? No. At a time I want to get the relation between T1, T2, K1, K2 with the same formula. For that I am doing something. I am doing equation number 2 minus 1. What's coming in equation? Log of K2 minus log of K1. Left side I am doing. Right side also do that one. This one minus of this one. Then what happening? Log A will be cancelled. Then what is remaining? Minus EA by 2.303 into R into 1 by T2. Minus of minus is becoming plus EA by 2.303 into R into 1 by T2. Do simplification. Log A minus log B. Log A minus B. Yes, very good. Log A by B. Log K2 by K1 is equals to. Here we can take EA by 2.303 or take it friend. EA by 2.303 into R. Then what is remaining? 1 by T1 minus 1 by T2. You can do simplification. Log of K2 by K1 is equals to EA by 2.303 into R into take LCM. T1 T2 is the LCM. Yes or no? What is coming then? T2 minus T1. This is the final formula. Derivation is not required for you. At a time you want to get two rate constant at two different temperatures. Log of K2 by K1 is equals to EA by 2.303 into R into T2 minus T1 by T1 T2. I told very clearly at T1 temperature rate constant is K1, at T2 temperature rate constant is K2. This graph is important especially for competitive point of view regarding slopes. If you take 1 by T versus ln of K, slope is negative minus EA by R. No, you are taking 1 by T versus log of K, then you are getting slope is minus EA by 2.303. Only this is extra because ln and log. Yes. Okay, just one small extension from this Arrhenius theory. Arrhenius equation A is equals to A into e power minus EA by RT. Till now, what we discussed, the whole concept is called as collision theory. So, according to collision theory, what is telling in activated state, the reacting particles are having very much energy. With that much energy, they are involving the collisions. They are calling as effective collisions. Definitely, then they are converting into products. But here, small problem is there. Just I will explain to you. See, if you take here which one reaction coordinate. Or nothing but reaction progress. And here we are taking which one you are taking? Kinetic energy, energy you are taking, whatever energy it is, energy of the reactant you are taking. Reactants are there, they are converting into products. Okay, now this state we are calling as which one? Activated state. Okay, you see very carefully. Till now what we did in the activated state, reactants were having too much energy. With that energy they are involving in the collisions. Those collisions are definitely converting into products. Those collisions only we are specially calling as effective collisions. But here one extra point you have to introduce. Even though collisions will be going with high energy, they may not be forming products. They will be forming products based on orientation. Proper orientation of reactant should be involving in the effective collisions. Did you got my point there? Till now what we learned in the activated state collisions is going on, they are calling as effective collisions, definitely they are converting into products. But here some problem is coming. Whatever collisions going in activated state all may not be converting into products, only few are converting into products. So which are converting into products? Which are having a proper orientation of reactant under effective collisions. This concept only can be explained or modified or rectified with the help of one of the factor. It is nothing but the orientation factor. Orientation factor is denoted by P. So that can be introduced in this one. That is only we are calling as final Arrhenius equation. K is equals to P into A into e power minus EA by RT. The P only we are calling as orientation factor. Means what is this one? It will give a proper orientation reactants to effective collisions. For example, you have CO plus NO2. They are in the activated state. They are involving in the effective collisions only if you are converting into products like CO2 plus NO. Okay, what is the different possible orientations of collisions in the activated state with these molecules? First case I am telling you, see carefully. You take carbon and oxygen, make it as a spherical bodies. Combining with which one? Nitrogen and oxygen, NO2 molecule is like this. From NO2 molecule, actually these collisions is happening in the activated state, but they are useless. Why? They are not having proper orientation in the collision. Okay, how it is that one? From NO2 we are getting which atom? Nitrogen atom. From carbon monoxide, which atom is involved in the contact? Carbon. Then is there any chance to form CO2? No. Why? Carbon is connected with the nitrogen. Means it will pull nitrogen. It will not possible. That's why we are not getting any products. Because no proper orientation collision is going on. No proper or improper orientation is going on. That's why even the collision is happening in the activated state useless. Okay, then you can see one more. You take for example C and O. But from NO2 what is coming? O, N, O. Yes, you see carefully. From NO2 which is involving in the contact oxygen. Yes, it's a very good orientation. Then what happens? If you put the oxygen, it is becoming like CO2 plus NO. This is only we are calling as proper orientation. Yes, like so many collisions will be going on. How many are proper orientation? That number we calling as orientation factor. Can I give one more example or one more improper orientation? You take for example O and C plus or otherwise if you can take one more O, N, O. Yes, what happened here from NO2? Oxygen is contact. From CO, oxygen is contact. Is it possible? No. Why? Both are like particle, unit particle. That's why here also no products, which is also improper orientation. That's why just I shown three